Lesson: Composite functions. Good composition is like a suspension bridge. Each line adds strength and takes none away. Robert Henry. Definition: given two functions f and g, the composite function, denoted by f composed with g, is defined by f of g of x. The domain of f composed with g is the set of all numbers x in the domain of g, such as g of x is in the domain of f. The term composition of functions refers to the combining together of two or more functions in a manner where the output from one function becomes the input for the next function. The input of a function g is x. The output of the function g is g of x. The input of a function f is g of x. The output of the function f is f of g of x. The domain of g is mapped to the range of g through the function g, such that x becomes g of x. The domain of g is inclusive or equal to the domain of f. This is then mapped through the function f into the range f composed of g. The range of f composed of g is included or equal to the range of f. Find the domain in the equation of the composition of functions f and g, such that f of x equals x over the quantity x minus 1 and g of x is equal to square root of the quantity x minus 2 minus 3. F composed of g of x can be written as f, then we translate the composition symbol as a bracket, of g, and then we take the value x, g of x. Substitute the inner function g of x by what we know it is to be, which equals f of square root of x minus 2 minus 3. In the equation of f, substitute every x by square root of x minus 2 minus 3. Thus, at the numerator, we have square root of x minus 2 minus 3, and at the denominator, we have square root of x minus 2 minus 3 minus 1. Combining like terms, we obtained our final result of square root of x minus 2 minus 3 over the quantity square root x minus 2 minus 4. Quick reminder, when dealing with composition, always start with the function on the right. Our final answer is f composed with g of x is equal to the square root of x minus 2 minus 3 over the quantity square root of x minus 2 minus 4. The restrictions on this are as follows. The quantity under the square root must be greater or equal to 0. X minus 2 is greater or equal to 0, which is equivalent to x is greater or equal to 2. The denominator cannot equal 0. Square root of x minus 2 minus 4 does not equal 0. Separate to different sides of the equation and square both sides. This is equivalent to x minus 2 does not equal 16, which is equivalent to x does not equal 18. Taking these restrictions and drawing out the number line, we can see that the domain of f composed of g is equal to closed interval 2 comma open interval 18 united with open interval 18 infinity. And the codomain of f composed of g is the set of real numbers. Given f of x equals 2x minus 1, g of x is equal to 5x minus x squared, and h of x is equal to 1 over the quantity 1 minus x, find f composed of g composed of h of 1/2. The first step we're going to take is rewrite this in a more workable form. So we'll copy it down as f, then the composition symbol translates to a curly brace of g, translate the next composition symbol into a normal brace, h, and then our value of 1/2. Close off our braces to finish off. This is equal to f of g, and then we take our value h at 1/2, plug it in, and find that exact number. So 1 over 1 minus 1/2. amplify this fraction by 2 to simplify, which is equal to 2 over 2 minus 1 simplifies to 2. So now we have f of g of 2. Doing the exact same thing, but now with the function g, we have f of 5 minus 2 squared, or 5 minus 4, such that we have f of 1. This is equal to 2 times 1 minus 1, which is 1. Final answer, f composed of g composed of h of 1/2 equals 1. Using the table definitions of function f and g shown below to find the composition of the two functions at the indicated value. A, f composed of g of 4. Translating this, we get f, open brace for the composition, of g of 4, close brackets. G of 4 is equal to 2, thus we just have f of 2. F of 2 is equal to 3 according to the table, so the final answer of f composed with g of 4 is equal to 3. B, f composed of g at 6 is equal to f, composition symbol, so curly brace, of f, another composition symbol, normal brace, of g of 6 as our final value. G of 6, according to the table, is equal to 3, so we have f of 3. F of 3 is equal to 1, so we have f of 1, and f of 1 is equal to 4. So in conclusion, f composed of g of 6 is equal to 4. Refer to the graphs of functions f and g shown below to find the composition of the functions at the indicated value. A, f composed with f of 3. This is equal to f, open brace for composition of f, another brace, f, finally 3. F of 3 is equal to -1, so let's plug that into our question. F of -1. Then we need to find f of -1 on our graph, which is equal to 2. That simplifies to f of 2. And f of 2 is equal to 0, such that our final answer, f composed of f of 3 is equal to 0. B, f composed of g is of 3. This is equal to f, open brace, g, open bracket, g of 3. G of 3, according to the graph, is equal to 0. So we can write this as f of g of 0. G of 0 is equal to 1. So in our next step, we can just write this as f of 1. And f of 1 is equal to -2. Thus, f composed of g of 3 is -2. Let h be the composite function of f and g. Find the components of the composite function. H of x is equal to the quantity x cubed plus 1, everything to the 4th. The function h takes x cubed plus 1 and raises it to the power 4. A natural way to decompose h is to raise g of x equals x cubed plus 1 to the power 4. If we let f of x equals x to the 4th and g of x equals x cubed plus 1, then f composed with g of x is equal to f, open brace, as we translate the composition symbol to brace, g, and then of x, which is equal to f of x cubed plus 1. Then we plug in x cubed plus 1 as our x in our f of x function, and we obtain, open parentheses, x cubed plus 1, everything to the 4th, which is equal to h of x. Important, The components of the composite function are not unique. A different way to decompose h is let g of x equals square root of x and f of x equals the quantity x to the 6th plus 1, everything to the 4th. F composed with g of x is equal to f, then we translate composition as bracket of g, and then finally the value of x. Plugging in for g of x, we obtain f of square root of x, and then we take that square root of x and plug it into our f of x equation such that we have open parentheses square root of x, everything to the 6th plus 1, everything to the 4th. Now when performing calculations, x to the 1/2 times 6, we get x to the 3rd plus 1, everything to the 4th, which is equal to h of x. If f of x equals 3x plus m and g of x equals 2x cubed minus 14, find the value of the constant m so that the graph of g composed with f crosses the y-axis at 40. If the graph of the composition crosses the y-axis at 40, then the point P, 0, 40 belongs to the graph of the function. Thus, g composed with f of 0 equals 40. This is equivalent to g of f of 0 equals 40. Plugging in 0 in the function f, this is equivalent to g of 3 times 0 plus m equals 40. Or g, which is equivalent to g of m equals 40. This is then equivalent to 2m cubed minus 14 equals 40. Bring 14 to the other side of the equation by adding both sides by positive 14, equivalent to 2m cubed equals 54. Divide both sides by 2, equivalent to m cubed equals 27. And then raise both sides to the power 1 over 3, equivalent to m equals 3.